Hello everyone. So we are at level 3 of time, speed and distance, and I hope that you've gone through the foundations, you've gone through the previous year questions, and by the end of level 3 we will be sure that we have mastered this topic. All right. So a bus starts at 9 a.m. and follows a fixed route every day. One day it had traveled at a constant speed of 60, reached its destination 3.5 hours later than scheduled arrival time. Let the scheduled arrival time be t, let the normal speed be s, and distance we know it will be st. One day traveled at a constant speed of 60 kilometers per hour and reached its destination 3.5 hours later than its scheduled arrival time. So it starts at 9 a.m., ends at we don't know when, but it took 3.5 hours more than the scheduled arrival time. Next day, it traveled two-third of its route. So this is d. Let's say 2d by 3, two-third of its route in one-third of its scheduled arrival time, so t by 3, and the remaining part at 40 kilometers per hour to reach just in time. So it will take 2t by 3 for the remaining part, the scheduled arrival time. We have to find out t, and we know that this has happened. Um Next day, travel two-third of its route in one-third of its total scheduled travel time and the remaining part at 40. So we don't know what speed it has used here. We can assume it to be 60, but it's not implicitly written in the question. Let's see. So can I say that at 60 speed and taking 3.5 hours more, it covered distance d, which is given from the first data, and 9 a.m. will be used at the end to find out the answer. Uh, Here also, if I put 60, this I can easily solve. 2d by 3 is equals to, let's say it was x speed and it took 3 by 3 time, and d by 3 is at 40 ka speed with 2t by 3. So if you divide the two, you will get this, right? So x comes out to be 160 kilometers per hour. So this I know, and I need to find t. So let's put in one of the equations. 2t by 3 is equal to 160 by 3 into time t. 3 and 3 will get cancelled. This will be 80. Distance is 80t. Put it here. So 60 t plus 3.5 is 80 t. 60t, it will come here. It will become 20t. And this will 60 into 3.5. This is 3. So t will be 10.5. Now that I know t, I can find out if you start at 9 a.m. and it has been 12 hours, it would be 9 p.m. But it is 10 hours, so 7 p.m. and 10.5 hours, so 7 p.m. plus half or 7.730 p.m. Option number D. Yeah, pretty easy question, but you have to be good with your concepts. A boat takes 2 hours to travel downstream from port A to port B. This is the boat we have done in foundation basics of upstream and downstream, and 3 hours to return to port A. So it comes back also, and it takes 3 hours this time, and it takes 2 hours this time. Another boat takes total 6 hours to travel. Okay, there's another boat, and it takes to come and go total 6 hours from port B to port A and back to port B. So it will first go up and then it will come down. And this is the boat. It is first going up, then coming down. Okay, if the speed of both the boats and the river are constant, the time in hours taken by the slower boat. So we have to find out both of their speeds. Can I say boat speed as u and current speed as v? And there's another boat, so probably u dash, because it's, I don't know if it's slower or faster, but it has to be different. because it is saying slower boat, and by saying that boat and river speeds are constant, so it is saying that river current is same v. Okay. So simply let's make the equation distance, let it be d. So distance traveled by the first, uh, and the speed will be u plus v when you're going downstream, and then when this comes out to be 2 hours, then when you're going upstream, it will be u minus v. That was 3 hours. In this case, distance upon upstream will be this, and distance upon downstream will be this. Total, it is taking 6 hours. That's what I know from all the information that is in the question. I need to find u dash and u. Probably it will become a quadratic. And let's just equate the two. 2u plus 2v is equals to 3u minus 3v, or u is equals to 5v. That is our first equation. Don't confuse u as 4. Be very mindful of how you're writing. And if I use d in this case, can I say it is 6v? So 12v. Now if I put it here, what is the point? But if I use v in terms of u, I don't want that. Let's just put distance, because anyway I want everything to be in v. So can I say 12v and take it there on the other side? So this is probably, we can write this as 6 upon d, or 6 upon 12v, or 1 by 2v. I will get u dash in terms of v, and I have u in terms of v, so probably I'll get somewhere in terms of the slower one. Let's read the question again if we've missed anything. 2 hours we've used, 3 hours we've used, 6 hours we've used. Nothing else is there. Okay. It will come. Let's see. So if I do what I can, so I'll just go ahead. So it will become 2u dash, and below it will become this. So it will be 2u dash 4u dash v square 4u dash v is equals to u dash square minus v square. So u dash you want, right? So it's a quadratic, and there's nothing else we can do about it. Let's just solve it. Now this is basically a quadratic where in u dash. Okay. So you know u dash will be minus b plus minus root b square minus 4ac. C is minus v square. So this is basically 4v plus minus root 16v square plus 4v square 20v square upon 2a. Don't forget that. So upon 2a. This also upon 2a. Now this comes out to be 4v plus minus. This is 5 into 4. So 2 will come out, root 5 will stay, and v will stay upon 2, or 2v plus minus root 5v. So 2 plus minus root 5 into v is the other speed, and one speed was 5v. So this is what, 2 point something, right? So this is 4 point something at max, or negative it cannot be. So it has to be 2 plus, it cannot be 2 minus root 5. Your speed cannot be negative. So it is 2 plus root 5v for sure. This is your first speed, this is your second speed, and the slower one is this. So we need to find out the time, and time will be distance. Distance was 12v upon speed, and speed, time taken by the slower boat to go from port A to port B. So we know the slower boat will be uh, u dash. This is the slower boat, and it is asking the time taken by it to go from port A to port B. When it is going from port A to port B, its speed will be downstream, so it will be greater. So u plus u dash plus v, and u dash is 2 plus root 5 into v plus v. So it will be 12v upon, this is 3 plus root 5 into v and v will get cancelled. So 12 into 3 minus root 5 upon, this is 9 minus root 5 का whole square or 4. So 3 into 3 minus root 5. Option number C. Let's go with question number 3. Train A and B, they start traveling in the same time towards each other with constant speed from station X and station Y. There are two trains A and B, and they start moving each towards each other. Now it is saying that the train A reaches station Y in 10 minutes. Let the speed be SA and SB. So I can say, and let this distance be D. So to cover D with the speed of A, it is taking 10 minutes. Now assuming that the speed is in meter per minute. So all the distance are in meter and uh, time are in minutes. So this is good for now. While train B, this is train B. It takes 9 minutes to reach station X after meeting A. So they will meet somewhere here and then they will go in their respective distance. So it is saying that the train B is taking 9 minutes to reach station X after meeting. So let's this distance be X. This will be D minus X. Okay. So can I say that to cover X distance with its speed B, it is taking 9 minutes. That's what the question is saying. Now that we have introduced X, when they met, to cover X by train A will be the same time D minus X distance covered by train B. So what do we need to find? The total time taken by the train B to travel from Y to X. Basically D upon SB. This is what the question wants us to find. Okay. So if we use the information that we have, can I say SB upon SA is D minus X upon X? And from here, if I want to find SB upon SA, can I just divide the two ratios? So this becomes D upon SA, SB by X is 10 by 9, or SB upon SA is basically 10x by 9D. Equate the two, D minus X upon X is equals to 10x by 9D. Is something getting answered? No. Okay, let's just go ahead. 90 square minus 90x, 10x square. We got a quadratic. Doesn't look like the options will demand a quadratic, but okay, let's go. So what do we want? We want SB, and we know SB is 9x by 9. So we want basically x values. So let's make a quadratic in x. 10x square minus, no, 10x square plus 90x is minus 90 square is equals to 0. Let's solve this quadratic. So basically x will be minus b plus minus root b square minus 4ac upon 2a. So minus 90 plus minus, what is this? 936, 360 and 81, 12, 13, 14, 441. 441 we know is a perfect square. So we're getting somewhere. What is 441? 20 is to 400. So basically 21 ka square is 441, right? You remember, it's great. Otherwise, doesn't matter. Just quickly calculate. So minus 90 plus minus 21d upon 20. Speed cannot be negative. It has to be positive. So 21d minus 9d, 10, 11, 12d by 20. This is x. Okay, we've got x, or 6d by 10, or 3 by 5, 3d by 5. So x is 3d by 5. Now I've got x. I need to find time, d upon sb. I need sb, which is x by 9. So sb is x by 9, or d by 15. And I need time, which is d by sb. We got the answer, d by sb, or D by 15 or 15. 15 minutes is the answer. So looked like third B. Yeah, it looked like quadratic should not be there, but because it was getting a perfect square, I would have stopped at quadratic and like reassessed what am I doing. And but still, because I got perfect roots, I was sure I'm in the right direction. Let's go question number 4. Two ships they meet mid-ocean, and then one ship goes south and the other goes west. Okay, they meet mid-ocean. One goes south, one goes west. Both traveling at constant speed. 2 hours later, they're 60 kilometers apart. 2 hours later. If the speed of one ship is 6 kilometers per hour more than the other, then find the slower ship. We have to calculate both of their speeds, but we know that one ship is 6 kilometers more. Any one way I can assume as slower. So let this speed be x. This speed will be x plus 6. And I need to find the slower one. So as soon as I get x, my answer will be x, right? So one is x plus 6. It's basically a simple Pythagoras theorem application, but they will cover some distance, right? So this will cover what distance? Its speed is x plus 6, and in 2 hours it will cover this much distance. Its speed is x. In 2 hours it will cover this much distance, and this has become 60 kilometers apart. Now that's it, man. 2x plus, let's go, 4x plus 6 whole square plus 4x square is equals to 3600. 4 will get cancelled. X plus 6 whole square plus x square is equals to this by 4. 907, 36, 900. Let's look at the options also. We need x. I can also substitute. I don't need to like really calculate. Let's put x as 18. So this will become 24 square plus 18 square. I know 4 square last digit will be 6. 8 square last digit will be 64. 4. So yeah, A can be true. Can be true. Let's eliminate. B is 24. Let's put 24. That means 30 square plus 24 square. Last digit will be 6. Last digit will be 0. Cannot be 0. So B is definitely incorrect. 12. 12 plus 6. 18 square plus 12 square. So 8 is 64 and 4. 4 and 4, 8. Cannot be. I think A is correct. But we should always check if there are multiple options. Then we would have exactly calculated. 6 ka square, 6 plus 0. So yeah. See, we don't need to find the exact answer. A is the exact answer. Fourth question. Yeah. So options are very important and basic logic is very important. Number system, we will be covering so many of such questions. All right, let's go to question number 5. Two trains A and B, they are moving in opposite direction. Train A and train B, they're moving in opposite direction. And their speed are in ratio 5 is to 3. The front end of train A crossed the rear end of the train B 46 seconds after the front end of the trains had crossed each other. So after some time, what will happen is the two trains will come towards each other. Let's assume length as this, and this has happened. Now, if you imagine what is happening is, let's just imagine it in slow motion. Train A will move further, and what is it saying? The front end of the train A crossed the rear end of the train B in 46 seconds. So basically, from here till here, it has covered its own length. So LA, it has, all right. So let's go to question number 5. Two trains A and B, they are moving in opposite directions. So there's a train A and there is a train B, and they're moving towards each other. Their speed are in the ratio 5x and 3x. Front end of the train A crossed the rear end of the train B after the front end of the trains had crossed. So what will happen after some time, if you look at it in slow motion, the front end of the two trains will meet. right? And it is saying that the front end of train A crossed the rear end of the train B. Now, if you look at it, A will further move ahead and the front end at some point of time will just touch the rear end of the train B, right? This is your train A and B would have crossed, but you can imagine that the train started from here and it ended here. Front end made the rear end, so it has actually traveled the length of train B, and the speed will be increased because they are moving towards each other, and it took 46 seconds to do that. Let it be in meters, let it be in seconds. Now, it took another 69 seconds for it took another 69. So it is still moving. And now what will happen is it will again move forward. It is saying it took another 69 seconds for the rear end of the trains to cross each other. Now, this is the rear end and this is the rear end. So this rear end to cross each other, it has traveled its own length. Now from here till here, it has traveled its own length till its rear end will touch its rear end. We're just assuming it in to be stationary, this second train, so that we can imagine. Otherwise, it's happening while this train is also moving. So this is one way to imagine. So it has actually covered its own length. Again, the speed, relative speed has increased and it took 69 seconds. Now find the ratio of the length A to length B. That's it. I think denominators are also same. So let's just divide second upon first. LA by LB, 69 by 46. Option number B. Yeah. So you have to do a lot of train type questions to actually be able to understand what is happening in slow motion. Leaving home at the same time, Amal reaches the office 10:15 a.m. if he travels at 8 km per hour. So if this, let the normal speed be S, normal t time t, and distance be d. So it is saying that he's reaching office at 10:15 at whatever time he's starting. But if the speed is 8, now at 9:40, if he travels at 15, so he's reaching at 9:40 if his speed is 15. Leaving home at 9:10, at what speed he must travel to reach at 10? Okay. We cannot know that he's always leaving at 9:10, but if he leaves at 9:10 and he wants to reach at 9:10 a.m., what should be the speed? Okay. Let this be, let's just see the whole scenarios in equations. Okay. So 8 is the speed, t is the time that he's taking to cover the same distance, and 15 is the speed, t2 is the time that he's taking to cover the distance, t1, t2, t3. And t3 we know is 50 minutes. And we know t1 and t2. T1 is he's leaving at the same time, and t1 time is something, and t2 time is 15 and 20 minutes. 35 minutes less than. So can I say t1 is t2 time is less, right? Because speed is more. So can I say t2 is less? So t2, if I add uh, 35 minutes to it, then t1 times become, because he's leaving at the same time and he's reaching 35 minutes earlier at an increased speed. So this time will be less. So I need t3. So I know he's taking 50 minutes at some speed to cover the same distance d. And I need to find out speed. Let's put d by 8 as t1, d by 15 as t2, and everything is in minutes, and distance is in kilometer per hour. Okay, this speed is in kilometer per hour, and time I'm taking in, again, hours only have to take. So 35 was the minutes, so in hours this. Here it will all get cancelled, so it doesn't matter. But again, D1 was in hours and it was in kilometer per hour, so distance is in kilometers. Correct? And this is D upon 8. So this is correct. Now let's solve for D. So this is what? 35. Should I? Let's do it. 7, 12. 15 minus 8, 9, 10. 7D upon 8 into 15 is equals to 7 by 12. 7 and 7 will get cancelled. 2, 3, 3, 5. Distance is 10. So we are on the right part. Distance is 10, so speed is 1 by 5. Speed is 1 by 5. 10 upon 50. Distance is 10 kilometers. Speed is 1 by 5 kilometer per hour. At what speed he must travel to reach at 10 a.m.? 50 minutes. See, again, when you're taking 50 minutes, you have to convert it into hours. Then only this will make sense, right? So this is 50 upon 60, which will go in numerator. So this actually becomes 12 kilometers per hour. So you have to be very mindful of playing with unit 6th D. And everyone makes mistakes. You have to come back to the question every time the options are not making sense. Question number 7. In a car race, car A beats car B by 45 kilometers. So in a car race, what does this mean? We have discussed basics of racing. Car A beats car B by 45 kilometers. That means let's let the total distance be D, and it is saying that car A reaches to the end point, car B is still here, and this distance is 45 kilometers. That's what it means. Car B beats, then again, B will reach the end, but C is still behind. So car B will beat it by 50 kilometers, and car A beats. So when A was here, B was here, C was somewhere here, and this was 90 kilometers. Car A beats car C. So the distance over which the race has been conducted. So D basically we have to find. Again, very simple. Speed, let it be SA, SB, SC, and just start making the equation. So D D distance was covered by A in the same time as D minus 45 distance was covered by B. D distance was covered by B when D minus 50 distance was covered by C. D distance was covered by A when D minus 90 was covered by C. Right. Now what? To find out D. Got it. So SA upon or SB upon SA from here can be written as D minus 45 upon D. Basically, I want SA, I want this to happen. SA upon SB, SB upon SC, SC upon SA, and then multiply these three so that I get one on one side. So in fact, I should find out SA upon SB. So D upon D minus 45. SB upon SC, D by D minus 50. SC upon SA, D minus 90 upon D. Now multiply these three, we'll get 1 on this side. D and D will get cancelled. So D and D will get cancelled. Of course, some quadratic will happen. D minus 45, D minus 50, D into D minus 90. Can we do it from the options also? Let's keep an eye. Let's solve a little bit. D square will get cancelled. Minus 50D minus 45D plus 45 into 50 is equals to D square, which got cancelled, minus 90D. 90D will come here. It will become 40D minus 45D. So minus 5D. Oh, wow. There is no quadratic actually. D is 15 to 45 upon 5. 9 by 45, 450. See, no need to put options. 7th B. sometimes question is made in a way that it will become easier. You have to just believe that what you're doing is correct. A and B are 2 points on a straight line. Ram runs from point A to B. Rahim from B to A. Don't put R, put R and R dash after crossing each other. Of course, they will cross each other at some point. Ram and Rahim reach their destination in 1 minute and 4 minutes. Let's say they meet at this point. This is D minus X. This total is D. Now, after they meet each other, they reach at their respective points in 1 minute and 4 minutes. So, first of all, X distance covered by, let it be S. In fact, let's take it as SA and SB. Okay. So, X distance is covered by Ram and D minus X distance covered by B for them to reach at that common point. Now, remaining X distance covered by B, Ram and Rahim in 1 and 4 minutes. In 4 minutes, and D minus X distance is covered by A in Ram 1 minute. Ram is covering D minus X in 1 minute. Rahim is covering X distance in 4 minutes. Speed, everything is in what? Okay, let's assume all the distance to be in meters and all the time in minutes. So speeds are also in meter per minute. Okay. It's on you because it will get cancelled. So I can assume it like that. Now, what do I want? I want the speeds ratio. So okay. So SB upon speed of Ram to Rahim, A to B. So keep it like that only. Don't get confused. Okay, this we need to find. So SA upon SB is equals to X upon X D minus X. And can I write SB as X by 4, SA as D minus X? I'll get some equation. Or I can get SA upon SB also. But let's see. D minus X upon X by 4 is equal to X by D minus X. So 2 into D minus X whole square is equals to X ka square. Or 2D minus 2X is equals to X. 2D is equals to 3X. Now 2D is equals to 3X. So SA upon SB, put anything, X. Let's put D as 3X by 2 minus X. This is 2. 2 by 1. 2 is to 1. 8D. Yeah. It looked like it should be root 2. It should be something like that, but it's just to confuse us. Let's go. Question number 9. Two circular tracks T1 and T2 of radii, not length, 120, touch each other at point A. So this is 100 meters, 20 meters. Starting from A at the same time, Ram and Rahim walk on these two tracks. 15 kilometers and 5 kilometers per hour. Kilometers, and that is in meters, okay? Number of full rounds that Ram will make before he meets Rahim for the first time here. Of course. So if you've gone through that circular motion video, you would be able to quickly calculate that how many, when will they meet again at the starting point. But I'm assuming that you don't know anything and we are going to do it with common sense. Okay. So let's just write down whatever we know. We know that he's going to cover 2 pi r and his speed is this. So time taken for one round. Time for one round. This is Ram. And if we talk about Rahim, he's gonna do 2 pi into 20 upon 5. So this is the time taken by him. Now let's say he takes 5 seconds to complete one round. He takes 3 seconds to complete one round. Okay. So by common sense, you know that he will keep on running and he will be slowly running, but they will not meet because in 3 seconds you would have already passed that starting point. But there will be a time when they will meet. So if you look at when Ram is touching A point, when 5 seconds, 10 seconds, 15, 20, 25, 30, and so on. Rahim, on the other hand, will touch the starting point at 3, 6, 9, 12, 15, and so on. So when will they meet? At 15 seconds. So this is basically LCM of the two. So if you look at it, we need to find out the LCM of the two times. So LCM of 2 pi into 100 by 15 and LCM of 2 pi 20 by 5. Put out, take things that are not required. So 2 pi will come out, 5 will come out, 20 will come out. So basically it is LCM of 5 by 3 and 1. Okay. In fact, take that 3 also out. LCM of 5 and 3, which what is 15. So this becomes LCM is 15. So 40 pi. So basically 40 pi is the time when they will meet at point A. By that time, he's asking how many rounds Ram would have made. So time total is 40 pi. And the time taken for Ram to make one round is 2 pi into 100 upon 15. So 3. Basically 3 rounds. Yeah. Just common sense. We don't need any shortcuts. It's just being comfortable because you've done circular motion certain questions, then only you'll be able to attempt it. Otherwise, it becomes scary. So leave it. Then come back in the last 10 minutes. Vimal starts from office every day at 9 a.m. Reaches exactly on time if Vimla, sorry, if she drives, but it doesn't matter. For us, it is at a usual speed of 40 kilometers per hour. She reaches exactly on time if she drives at a usual speed. So usual speed is 40, usual time is t, usual distance is d. Now she's late by 6 minutes if she drives at 35 kilometers per hour. So if the speed is 35, she's late by 6 minutes to cover distance d. One day she covers two-thirds of the distance to the office in one-third of her usual time. Then stops for 8 minutes, wasted. Then the speed to cover remaining distance. This also we have done a few questions back. So 2 by 3 time is left? No. 2 by 3 time minus that 8 minutes that she has wasted, and she has to cover one-third of the distance for at some s dash speed so that she can reach on time. We need to find s dash. Can't assume this speed to be a normal 40 speed. Okay. Let's see. Let's just start using this information. At 40, she reaches exactly on time and she starts at 9 a.m. I think 9 a.m. is redundant. Doesn't matter. 40 into T is D. This is first. Also, look, 40 kilometer per hour. So time is in minutes. So let's just convert it into hours, right? So I'm assuming time is in hours. You have to assume one thing, right? So time I'm assuming in hours. 40 is D. Second, when she's going with 35 kilometer per hour. See this you have to convert so that this becomes also hours. So 6 plus 1 by 10. This also was D. So from here we can easily calculate time. 40t is equals to 35t plus 3.5. 5t is equals to 3.5. T is equals to 35 by 50. We just keep it like this for now. This is an hour. Now what has happened? It has covered this. Has to cover this much time. Again 8 minutes to make it in hours. And s dash will be speed with which it has to cover the remaining distance. Again D also I can calculate 40 t 8 kilometers. So now I know this distance. So speed is 1 by 3d upon 2 by 3t minus 8 fives of 40. 8 by 60. Let's keep it like this. Put the values. Distance 28 by 3. 2 by 3 into time, which is 7 by 10 minus 8 by 60. This is what? 14 by 30. or 28 by 60. This is 28 by 3 and this is 20 by 60. 1 by 3. So 28. 28. That's it. B 10th. Yeah. Let's look at the last question. Question number 11. A, S, and R move along a circular path of length 3 kilometers. Okay, length is 3 kilometers this time and not the radius. Starting from the same point and going clockwise. So we have A, S, and R, and the speed is 15, 10, and 8 kilometer per hour. How much distance would Ravi would have run when A and S meet for the first time at the starting point? Again, if you've done the video on circular path, you know it's pretty um, direct. But again, I'm assuming that you don't know, and we will use common logic. So the question is literally saying that when A and S meet at the first time on the starting point, which we just did a couple of questions back, how much distance would Ravi had run? So I just need to find what is the time that has elapsed when A and S meet at the starting point for the first time. So again, time taken by A to do one round will be distance upon its speed. So in this much hour, time taken by S to do one round will be 3 by 8. Now I basically need to find out the LCM of these two so that I can know the time, and then simply I can find out how much Ravi would have run. Sorry, it is asking how much Ravi would have run when A and S meet again. So time taken by A, time taken by S will be 3 by 10, right? Um, Now I need to find out the LCM. So you can convert it into minutes, but how do you find LCM of these two, right? Um, Basically, LCM of these two will be LCM of 3 and 3 upon HCF of 15 and 10, right? I hope this is clear. I mean, you can't just uh, so LCM will be 3 and HCF highest common factor of these two will be 5. So 3 by 5 is the time that is being taken by A and S to meet, and we need to find out how much Ravi would have run in this much time. So Ravi's speed is 8 kilometer per hour, and in 3 by 5 hours, he would have run 8, 16, 24 by 5 or 4.8 kilometers he would have run. So answer should be D. Yeah. In fact, you could have converted this also into minutes. If I can write it in minutes, this into 60 is 12 minutes, and this into 60 is 18 minutes. So you can now also you can do 18 and 12 LCM. So which is what? 6 twos are 6 threes are 6 into 5, 30 minutes, right? 6 twos are 6 threes are 3 twos are 6, 36 minutes, sorry. And in 36 minutes or in 36 hours, he would have run with 8 kilometer per hour this much distance. So this also will be 6 6 6 10 4 5 624 by 5 or 4.8 kilometers. So it doesn't matter if you're not comfortable in fractions, you would have easily done this. But if you get in a situation where you want to find LCM of fractions, you would have been solving it by taking LCM of numerators upon HCF of denominator. I've done a couple of videos where I've talked about basics of fraction, basics of percentage, ratios, average. Go through those so that they can create a base for your overall understanding of arithmetic and quant in general. All right, so this was for time, speed, and distance. Now that we've covered the three levels, you can be sure any question that comes on this topic you can handle. Also, keep on marking all the good questions that you find in these three assignments and whatever you find on the internet, so that once in a while, when you come back to this topic, you can quickly go through the star marked questions, and that will be a good way to practice. Next, we're going to take profit and loss in three levels, and I hope this series is helpful. Thank you so much. Happy learning.